In this video, we demonstrate the CertifyCDNO, showcasing its basic certificate issuance and verification functionalities. Before we move on to the prototype itself, there is a tool needed to make the usage and testing easier. It is a CDNO wallet called NAMI. The wallet acts as the identifier for the issuer or verifier, allowing them to authorize transactions and to interact with the smart contract. You can check out their documentation, download the NAMI wallet extension, and set it up. It has been successfully set up on my browser. Note, you would have to receive test data to your wallet from the CDNO testnet faucet. This is the link. The core concept of the system is to securely collect certificate details and hash the most unique identifiers, such as the certificate name, recipient information, and other key attributes. This hash serves as a cryptographic representation of the entire certificate, ensuring both privacy and integrity. Instead of storing the full certificate data on-chain, which can be costly and inefficient, the system submits the hash to the smart contract on the CDNO blockchain. The full certificate details, anchored by the hash, are stored off-chain using a database like IPFS. The verification process is designed so that a user enters key certificate details, e.g., certificate name, recipient information, which are then securely hashed on the back end. This hash serves as a unique identifier for the certificate. The system interacts with the smart contract on the blockchain, querying the stored data to check for a matching certificate hash. If a match is found, an API call is triggered to retrieve the full certificate details from IPFS using the hash as a reference. For the prototype, the hash would be displayed directly after it has been stored on-chain. It is copied and would be used for the verification. For the verification, it shows whether the certificate is on-chain or not, but does not retrieve the entire certificate data. The goal is to test the idea of the basic issuance and verification mechanism we propose with the blockchain. This is the interface of the prototype. This is how to create a certificate. Click on the Create button. Always connect the wallet first. Enter the details. These fields are subject to change to fit the institutional needs in the future during the final product development. Then click the Submit button. Sign the transaction with your wallet. The fee being charged is a dummy figure for the prototype. Its purpose is to curb misuse of the platform. Detailed explanation is in the governance framework and would be added to the final documentation. If it shows a double pop-up, close the second. After the transaction is submitted, click on OK. Do not close this yet. The most important thing needed to verify is the certificate hash. Copy it and store it at a place you can easily retrieve. Click Close. Below is the transaction ID, which can prove a transaction has taken place. You could first check it in your wallet. Alternatively, you can check using the Transaction ID in Cardano Explorer Preview or Cardano Scan Preview websites. This is the fee. $3.80 is sent to a smart contract. Transaction details showing funds transferred to a smart contract from a wallet. We have successfully issued a certificate. Now go back to the home page. You can click on the CertifyCDNO or use the back button. Now click on Verify. First, connect your wallet. It is already connected. Enter the hash of the certificate and click on Submit. Sign the transaction. There is no fee charged for verifying, but there would be a transaction fee which would be specified by the network for interacting with the smart contract. You can verify multiple times. Move downwards. You would see a message that a certificate with that hash is on-chain, as well as a transaction ID to check the transaction details. So, this is the basic principle that we tested out in the prototype. The underlying processes would be in the final documentation, as this is just a demonstration. We can also test it out with a wrong hash. the application would not be able to build the transaction because after querying the smart contract, no UTXO was associated with that hash. Occasionally, after signing, a transaction may not be immediately submitted to the blockchain. For your transaction to be confirmed, it must be included in a block that successfully propagates across the network. Sometimes, blocks experience delays or fail to propagate, meaning your transaction may not be included right away. To mitigate this, a good rule of thumb is to wait at least 20 seconds, then simply refresh and resubmit the transaction. This usually resolves the issue and ensures your transaction is processed successfully. Although this rarely happens, thank you for watching.